When we are factoring, there are four possibilities. It's a little intense, I'm going to be honest. The ones that we're going to talk about, the one we're going to talk about today is grouping. Then we'll do quadratic in form in sum and difference of cubes next week. Those are kind of like the special cases. They're a little bit more difficult, which is why I want to get practice with the easier ones before we move on. We've actually done grouping before. I just didn't call it grouping when we did it because it wasn't set up that way. We had to do other things with it first. I think you're going to like grouping. I think it's going to be the easiest one. So while there's a lot of problems on today's assignment, it's because grouping is the most common and the easiest to understand. So I wanted to make sure we have that one down before we move on. We are going to skip the formulas and the perfect squares and cubes for right now. We do not need those for today's lesson. We need those for part 2. Okay, and I'm actually going to skip just straight to the examples. I'm honestly not going to have a lot of steps or anything on these because they solve fairly naturally. Okay, on the left, notice that it says factor completely. That means I want you to keep checking and making sure that there isn't anything else you can do. We have not been factoring completely because we hadn't done this lesson yet. So I've been kind of just letting us leave things not completely factored. Now, did you notice that? No, because you didn't even know what this was yet. It will change some of the things we've done a little bit, okay? And I will warn you, there is one piece that is not specifically in the notes that is on the assignment because we just practiced it on the synthetic division assignment. And it has the same corrections as the synthetic division assignment. So we will do one of those together. I just decided to leave it off of notes for this one. So when it says by using a GCF, and it says first using a GCF, because that means there could be other things you have to do afterwards. There's probably going to be an X. Because this has a power of 3, we don't know how to factor things with the power of 3 unless we take an X and put it out front of the parentheses. Okay, and I'm looking for something that I can divide everything by. And that starts with an X, and then I'm going to look at the numbers as well. 2, 16, and 40. I can divide those all by 2. If you can make the number in front of X squared 1 or just no number at all, try it because that makes factoring 1,000 times easier. Then I'm dividing everything by 2, so that's just going to be 1, -8, -20. And I like to go through and do all the number parts first and then the x's. And then if I take an x out here, that's going to take a power away from all of these. So this one is just going to be x squared. This one is just going to be x. And the last one isn't even going to have an x on it. Now we are almost like covering up that 2x. It still has to be there, and we're factoring what's left. So we need two numbers that multiply to -20 and add to -8. I'm going to make my little list over here because I know some of us freak out. We don't know what multiplies to it. Or we know some of the numbers, but we're worried we don't know all of them. So I'm going to pick 1 and 20, 2 and 10, 3 doesn't go into 20, 4 does 5 times. And notice how I made one of them negative because it multiplies to -20. And I want to pick the ones that add to -8. None of them add to -8 right now, but this one adds to 8. All that means is I want the negative to go on the 10 instead of the 2. And then my last two parentheses are going to be x plus 2 and x minus 10. And you want this to be able to multiply together to get back to the original, so you do have to leave that 2x in front. What we will talk about at some point in the new year, depending on what schedule they pick for us, is how to actually solve the problem using these factors. That's kind of the whole goal of factoring, is to be able to solve equations. Okay? And we're going to do the same thing on the next one. Again, the point is to take something out so you can factor in normally what's left. So on this one, they all have an x, and all of these have a power of 2 or higher. So I can actually put an x squared out here. And I can divide all of the numbers by not 6, because 6 doesn't go into 15, but 3. And I'm going to divide all the numbers out front by 3 to start with. Do that. And then since I'm taking an x squared out, I take 2 powers away. So x to the 4th is now going to be x squared. X to the 3rd is just going to be x. And the 5 doesn't have any. Thank you, yes. Good job on my division skills today. I don't think I brought my white oven. Got it? I think I forgot it. Okay, and then if we wanted to factor this, we'd be looking for 2 numbers that multiply to -10. Because when there's a number in front, you have to multiply it by the last one. And the only thing that goes into 10 are 1 and 10, 2 and 5. One of them adds to 9, the other one adds to 3. So this does not keep factoring because those numbers don't exist. Sometimes all you do is pull out the greatest common factor, and what's left can't be taken any further. While there's no extra steps to this one, I feel like most people find this problem more difficult because they keep second guessing themselves, like they just couldn't find the numbers. There aren't the numbers on this one. And that's part of the reason why I will leave you guys with the answer key when we do these. And then that's it for GCF. Sometimes you keep factoring what's left, sometimes you can't. Grouping is super nice and easy because you're going to split the problem into 2 parts, do this greatest common factor thing. That's pretty much it. There are 1, 2, 3, 4 terms here. There have to be 4. Okay, so with grouping, and those things are technically called terms. That just means like 4 parts. X to the 3rd is 1 part, 2x squared is another part. They're separated by plus and minus signs. If there aren't, then you can't pick this method. And then what I'm going to do is focus on just these first 2 and take my greatest common factor out. So there's no numbers in common because one has a 1 in front of it, the other one has a 2, but they both have a power of at least 2. That's going to happen on every single problem. That it's probably going to be x squared on every single one because it's going to start with x cubed and have an x squared. And then you just simply take a power of 2 away, leaving this one as just x and this one as just 2 without the x squared. We're going to do the same thing with the last 2 terms. So now I'm going to focus on these 2. If this first one is a negative, you need to put a negative outside. So I know I'm going to have a negative, and then 4 goes into both of these. But not x because there's not an x on both of them. This number will always be just a number without any x's. And then -4 divided by -4 is 1, x. -8 divided by -4 is +2. And what should happen every single time is that these match. That is now your greatest common factor. So if I put one of those down here, it crosses out these two, and all I have left is x squared minus 4. The only tricky part about these is now I have to check this and see, can I factor x plus 2 anymore? No, because it's just x plus 2. But if there was a number that went into both of these, you would want to take it outside. And over here, this is difference of squares. And there's going to be quite a few of these on the test. The only way that this needs an extra step is if both of these are perfect squares. And they are both perfect squares. So this is going to be, I'm going to write diff of squares. That's just a fancy way of saying that this can factor more into x plus 2, x minus 2. Whenever you have two perfect squares that are being subtracted, you're going to do the square root of this one, which is x, square root of 4, which is 2, and write it twice, one with a plus, one with a minus. This is how most of us will leave our answer. I just want to tell you that this is possible to also write it like this. And I'm going to circle both of them as my answer, because some of us just aren't going to see that squared, and that's fine with me. That is not one of the things I will ever count you off for. Because there's two of these, you could simplify your answer a little bit by saying that it's just that squared. If you have two factors that are exactly the same. That is very rare, it doesn't happen a whole lot. And that is factor number 3. Not all of them keep going. This next one, no. And all we're going to do is look at the first two and the last two. So for these two, I can take out a 3, because the 3 goes into 3 and 12, and an x squared. Because again, it's almost always going to be an x squared, because there's an x squared on both of them. 3 divided by 3 is 1, and I have a power of 1x left. Negative 12 divided by 3 is negative 4. There was x squared, and now that's out here, so I don't need any on that 4. And then we're going to do the same thing with the 7x minus 28. This one's a little bit easier because the only numbers that go into 7 are 7, and that does go into 28. So I'm going to put a 7 outside. 7 divided by 7 is 1, x. Negative 28 divided by 7 is negative 4. The x minus 4 is the same, which is good. That means you've done everything correct. If it's not the same, let me know because something went wrong. And then what's left on the outside is 3x squared plus 7. Okay. And that is all of the notes that we're doing today, but stay on for just a second because I'm going to do one of the homework problems. Hello.
Good morning.
Good morning.
How are you?
Good.
Merry Christmas.
Oh, thank you.
Appreciate all that you've done. You're drinking the damage down the zip, so when you need a little pick me up at some point, you can do that.
Thank you.
Merry Christmas.
Merry Christmas. All right, I was gonna flip to the next page, but it's actually the back side of this one. I tricked you a little bit.
Just mine.
I don't know, I have 2. Maybe I'll raffle one away next week. So the notes are attached to the assignment on this one. I know it's kind of annoying, but the assignment was 3 pages, and I didn't want to waste a page, so I decided to save a few trees. I'll kill more later, probably. I'm gonna skip to number 16 because these are going to be GCF. So if you want to Actually, I didn't label the examples. This is going to be like examples 1 and 2 on the front side. This is going to be like examples 3 and 4. And it says it matches the exact words I used on the notes too, if you want to use that. The one that I didn't put on the notes at all is use synthetic division and the given factor to completely factor each polynomial. So this is the part that we just did on the last assignment, but we didn't keep going afterwards. Okay, so I'm going to put -4 in my little box for this one on 16. And then I'm going to fill in my coefficients. There is 1 0 placeholder right here because there's 0 x's. And I know those are probably going to give you a run for your money a little bit. If you don't get zeros on these, check to see if you maybe missed a 0 placeholder first before assuming I made a typo. They didn't tell me I might have made a typo. And I'm going to go ahead and finish my synthetic division here. And whatever is left at the end, we're going to factor. That's what this one means. So it's not really anything a whole lot new, just what we did in the last lesson continued. Okay, drop the 1. -4 times 1 is -4. -4 plus -1 is -5. -5 times -4 is 20. Plus 0 is still 20. This is not going to work out. Did I type it wrong? Probably not 0. It's -100. So I'm really glad I picked that one because guess what? It is not a factor. Which means you guys get 2 homework problems then.
Wait, so if
Because I actually want to do one that works. What?
So if it has like neighbors, it can't be factored.
Right. Yeah. Which probably means I thought this one factored because I forgot my 0 placeholder. Because if I didn't put that 0 there and this was over there, it would have worked out fine. Let's do one that actually works though. Because they can't have anything down here if you want it to be a factor. So let's go with 5. There's no placeholders on this one. Drop the 1 down. 1 times 5 is 5. -5 plus 5 is 0. There we go. That one works out nicely. So my answer here is x squared minus 9. This is a difference of squares, meaning that it's the square root of x squared, which is x, the square root of 9, which is 3, 1 with a plus, 1 with a minus, and then you add the 1 from the top back as well. Because if this was x cubed to start with, or x to the 3rd power, it should have 3 factors. The only exception to that rule is if one of the factors has an x squared inside.